Okay, so first of all, thank you very much for coming to this talk this afternoon, this code talk. Who here has had to do some kind of code review, security or otherwise? Yeah, good few hands. Who enjoys it? Like, who really enjoys that part of their job? You do. He's over there, everyone. Go hire that man, okay? Yeah. So, my name is Charles Roberts. I'm a senior security consultant with AWS Professional Services. It's part of our consultancy, paid for consultancy. And
I'm Pradeep Kumar. I'm same team in Charles. We're based in London. I'm infrastructure architect, so I literally have very tiny bit to explain here. The main magic will be from Charles.
Which means that when the code goes wrong, it's all my fault. Okay, so first of all, what problem are we trying to solve, and why are you all sat here? We're going to run through some scaling code reviews, the benefits and features of some of the different methods that you can use. That's going to be more of an organizational thing rather than a technical thing, but we'll move through it quickly. And then we're going to try and go into the bit that you're all here for, which is the demo itself. So the problems we're trying to solve is that as consultants, we deliver code to you, our customers, every single day. And we have exactly the same challenges you do, and so do our service teams. That is, like, what is the quality of the code like that we are giving to our customers? What is the quality of the code from a security perspective and other perspectives? And it's hard. And I tell you what, like, there's Amazon scale, and if you think we have magic tricks to do this stuff, we don't, okay? We have the same problems that you have. We have people doing this day in, day out, and it's just hard. So I'm not going to suggest a perfect solution today. I'm going to suggest some ideas, and then you're going to go away and take them away and build on them and do it better than me, probably. Okay, so enterprise-wide code reviews are challenging. Why are they challenging? So developers have tools, but they're inconsistent. A lot of these tools are open source tools. Nothing wrong with them. They're very good, really healthy, maintained community behind them. But are all of the developers using the same version of that tool? Do they all download the same version? Do they even use the same tool? I can tell you now, we are given a range of options, like use this tool or use that tool. So consistency is hard for developers. How developers apply that consistency is also hard. Do they do commit hooks? Do they do just scanning on demand? Do they do it when they remember it? So that's hard as well. So it's very inconsistent for developers. The other thing is developers like to work in IDEs. Who here has been a developer that has had to come out of their IDE to then fill in a ticket, fill out a spreadsheet, write a document? I'm seeing lots of nodding heads, yeah? Who enjoys that? Like, no one enjoys that stuff, okay? You get out of your environment, it disrupts your flow, you then fill out some spreadsheet, you then send it to some anonymous ticketing machine, and the next thing you get back is a telling off, right? That's how that goes, right? The next thing you get back is someone like me who says, oh, by the way, that S3 bucket probably shouldn't be public. By the way, I always go for that. I know we don't do that anymore, but I always go for it. I joined Amazon when that stuff still happened. Okay, so how do we solve that problem? We invented DevOps and we invented CI/CD, right? We created an entire industry around DevOps and CI/CD. We built tools, we built pipelines, we constructed specialists, DevOps consultants, DevOps people who now do nothing but build pipelines, okay? And how often do they get it right? Well, sometimes better than nothing, but who here reckons that they could bypass their CI/CD pipeline if they really wanted to? Yeah. So there are ways around, aren't there? Like, you know, Friday afternoon, something needs fixing, quick. Don't push the prod on Friday, just fix it in live. It's so much easier. Just bypass the pipeline. So there are challenges around DevOps and CI/CD as well. Security teams are good, but they are human. They do struggle with that. And like, you can raise questions about the debates of where we're going with Gen AI and is it fallible and infallible. Okay, we can go there if you want to go there. But security teams like me are certainly tired on Friday afternoons, and the last thing we want to do is look at your 1,000 lines of code. So yeah, we struggle as well. We struggle with the same tools as well. Visibility. So the other thing is that when pipeline tools run, you tend to get visibility in that pipeline. You then tend to get visibility maybe in the spreadsheet that you filled out that gets attached to the ticket. But who across the organization is looking at that and saying, do you know what? 9 out of 10 of our developers are all making the same mistakes. Maybe that's something we could improve. What's the feedback loop? Basically, there isn't. So these are all challenges that I've seen, and we work really hard at trying to solve those challenges, but I feel that they are challenges. And I was giving some thought to this and came up with some ideas. Okay, scaling code reviews is hard. There's a few models out there. Again, like, tell me if you know another one. You can have the central security team. These are clearly cylinders of excellence because they're security people, right? They know everything. They know everything about everything. And by the way, security people are not created. We are born that way. Like, literally at birth, your mother looks at you and goes, oh, it's a little security person. So basically, that's not true. Security people come from a wide range of backgrounds. And then, like, normally, the way it works is that something goes wrong. It's security related. You fix that, and then someone says, you're good at this. Guess what? You're a security person. And then you spend the rest of your career trying to get out of it. And if you get particularly sort of morose about it, you get promoted and you become a CISO. That seems to be how that goes. I noticed, I went to a thing called a security leaders happy hour yesterday. I didn't know security leaders had happy hours, like maybe happy 10 minutes here and there if you're lucky, but a whole hour? Okay, so central security teams are problematic because they don't scale. Like, I'm sure here everyone has a shortage of good, well-qualified security people in their organization. You are probably those people. And you're here this week, so who's doing the code reviews this week? No one. Okay, that's the problem, is it doesn't scale. So the way that we've adopted in AWS, which is not, it's not unusual, is this kind of security guardian, security champion, building a culture of security. Security is our top priority. So the idea here is that we still have our centralized security specialists, but they are sort of evangelizing and they're pushing out to people who are part of the developer teams, and we give them enough knowledge to take on, if you like, a secondary function. They are the one who, at the end of a day, goes, hang on, have we considered security? They run the checks, they make sure things happen. So basically, centralized security doesn't scale very well. You just get really tired security people, and you can never hire enough of them. The problems with security guardians and security champions is it's a little bit like our developer tools. It scales better, but the problem is that they're all human. Are they all applying the company policy exactly the same way? Are they all as diligent as they should be? The answer to that question is no, because they're human. They get tired. Some of them will be new. Some of them will be tenured. Some of them will have their pet favorite things, and some of them will ignore other things. So the inconsistency is the issue you get with security guardians. Good news is they're closer to the code. So where do we go? Well, of course, we're going to use generative AI, aren't we? Because, like, if you haven't got the message, that's what we're going to do. Like, everyone's going to do generative AI with chips. Lots of chips, as it turns out. So generative AI, MCP, and tools. I'm going to run through some terms. You probably know these terms. If I see lots of nodding heads, I'll move on faster. So the idea here is that I want to do is I want to keep developers in their IDEs as much as possible. I want them using the tools that they use as much as possible and not creating spreadsheets. The objective is not to build a better spreadsheet. That's not my goal. So from that, that becomes a client, and then we've got this thing that is emerging called MCP. It stands for Model Context Protocol, and effectively, these are becoming what is described as like a USB-C interface between generative AI models and the back-end tools, okay? The solution we're going to show you today doesn't use MCP. I just want to be absolutely transparent about that. I would love to have done that. I use it on my own IDE, but we didn't use it in this solution. Give me another 2 weeks, I'm sure I'll use MCP, okay? So MCPs act as an interface, and then we can interact with our LLMs And here, of course, it's AWS, so I've said Bedrock Agents. And we are going to be using Claude 4 today if anyone is interested. Why? Because they said it was good at doing code stuff, so that's why I used it. I have not done rigorous testing on every single model we have, but it does do a pretty good job. The problem with LLMs is they're trained at a particular point in time. It's like they get to a point in time and their knowledge is frozen. We've all been there. What does that cause? Hallucinations. So that's a problem. We all know about that. How do we address that? We give them tools. The tools allow them to do things like query a URL. It gives them the ability to look at a knowledge base. It gives them the ability to maybe query a database. So to be honest, without tools, LLMs are pretty limited. And I think most of you probably know that. You're probably seeing that in your day-to-day, that they are so much more useful if they can do things with tools. Like classic, how many R's are there in strawberry? LLM will get that wrong, but if you combine it with a Python script, it can tell you how many R's there are in strawberry. That's the trivial one. Okay, so agents and agentic. An agent is an LLM. Agentic is an agent that is allowed to do something that a human would be allowed to do. So an agentic architecture is one where we're allowing the agents to actually take control, think autonomously, and take some actions. And hopefully, as long as the demo works, we'll see some of that in the logs. Okay. So the next thing we have is we want to try and make a supervising agent that can control lots of different agents. So the idea is that we have LLMs are really bad if you give them too many tasks. So what we can do is we can have different agents performing different specialities, and then they can be coordinated by a supervisor. Yeah, so this is just like, basically a project manager. Have you done your Jira tickets? Yeah, of course. Well, the agent probably has because it's a robot at the end of the day. The supervising agent coordinates the activity and returns the output. And then after that, we could submit to someone for a review. So the next thing we're going to do is jump into the code demo.
Yeah, there we go. So as I promised, I will chip in only for a tiny bit. And what I'll try to do is try to keep it, may not be that interesting, but at least short so that the interest can continue with the demo Charles will produce. So as Charles mentioned, the pattern we are using is and I hope you guys can see it all right. Let me try to make it a little bit bigger. Is the supervisor agent pattern for managing the or orchestrating the task between different agents or tools which will perform the individual tasks. As Charles mentioned, it's not that we have developed this entire solution yet, what we would be demoing, but the good thing about this architecture is that it's expandable. It can expand to your needs. And as an organization, learn or adopt to new tools, all you have to do is a simple way to plug in those tools to actually expand as your organization needs expand. So what exactly it would do is, first thing first, sorry, let me try see if I can make it a little bigger.
That's good.
Good? Cool, okay. So as the code is released in the Git repo, it would then trigger the sort of everybody of us who have done the DevOps, the post-commit trigger, which will then invoke the supervisor agent. It will identify what exactly it has to do, or in other words, which particular agent next it can invoke so that it can bring the flow in to start delivering. And what it would do is it will go and do the security review agent invocation, which will then in turn go and identify what kind of code you got. So for example, you got Terraform. Okay, fair enough. For Terraform, I got a Chekhov tool which can actually scan it. So it will invoke that tool, use that tool, generate the report, and pass the information back that the report is now generated. Supervisor managing the orchestration will next go to the issue analyzer, which will then analyze all those issues. Oh, okay. Do you want me to categorize? Yes, any critical or high, let's actually fix them straight away and raise a merge request so that the developers can actually just review and merge it back. Or let's say if it's low or medium defects, all we want is, can we actually just put a Jira ticket out there? And these are the parts which, as I said, not completely developed, but can be enhanced or added on to achieve those. And then further, the orchestrator will go and invoke the integration agent from the Git's perspective, which can then merge that code back or raise a CR back, into Git. Yeah, that's pretty much from the architecture perspective. Any questions on the architecture? No? Okay, cool. So what I'll do is I'll quickly jump on the deployed infrastructure which we have on AWS account. The demo will happen from the local machine. The reason being it's more interactive. It will show the log flowing, and it will be more visibly better than online. This is, I would say, one of the easiest architecture I had to build. There are 4 different ways, or simplest ways, you can actually deploy your agentic infrastructure on AWS. For example, you can use Lambda, you can use Fargate with ECS, you can deploy typically any compute as you use on AWS. You can do EKS or you can use EC2. What we have done is I just use the Fargate profile for an ECS. So a simple service running using fast API, which Charles will talk about when he will do the demonstration. That service exposes an HTTP endpoint using a simple load balancer, and hitting that load balancer will invoke the supervisor flow and start doing the magic it has to do. So apart from the networking around this, literally that's it. That's all it has. Number of tasks which works on serverless Fargate, and then keep coming as you need those to run the flow. Yeah, over to you, Charles.
Great. I'm a gentleman of a certain age that, like, if I stick the glasses on, I can't see you.
Same here.
If I don't stick them on, I can't see the screen. Yeah, and it's relatively recent, so I'm still getting the hang of it. So first of all, like, why should we? We're going to demo this on my local environment, and we're going to do that because basically I can tail the logs, and there was 2 ways that this was going to go. It was either going to be like watching paint dry because it runs and you don't see anything because it's in CloudWatch, or it runs and we can actually show you it. But what we did is we've built it in Docker. So the idea is like we would export this straight into Fargate. It would run in Fargate. And we've put an API on the front end of it. Why? Because we're AWS and we put an API on generally the front of everything. Someone once described ticketing systems as APIs for humans, which I quite liked. So we've put an API on the front of it, but why is that sort of relevant? Well, do you remember I said that one of the issues is like there's inconsistency across your organization. Everyone's running different tools, doing different things, different versions of different things. What happens if the policy gets updated by security? How is that ingested and used? Like, this information takes time to filter across. If you provide an API, you can centralize all of that, and then people can hit that API, then they get consistency. That's my logic. We'll see if it works. Okay, right. So first things first, who here has heard of strands? A few people. Great. Does anyone want to describe what it is?
It's a Python SDK for kind of writing generative AI.
Perfect. So we released it, what, about three weeks ago, something like that? 3-4 weeks ago we made the announcement. Strands, the idea is it's like a double helix of DNA. You've kind of got the SDK bit, which is partnering with the agents. When I started building this solution, I was going to do it using CDK, I was going to do Bedrock, and I was going to do Bedrock agents with a schema, with tools, and do you know what? It got complicated. I started to find it really got complicated. I found strands, and honestly, if you've got a bit of Python development experience, I really encourage you to go and find it and start looking at it. You'll be up and running very, very quickly just with your first kind of like hello world. It works straight into Bedrock, and you can start building really quickly. And what I'm going to do is I'm just going to walk you through quickly the kind of way it works. if I can find where I'm looking in here. So first of all, can everyone see that okay? So in the strands directory, we've got an app. And the first thing I'm going to do is I'm going to go to this agents directory. This is entirely, this is just Python, right? You don't have to construct it this way. I just did it this way because it was, 3 a.m. and I had jet lag. But, I've kept it nice and simple. I've kind of got agents and I've got tools. That takes me back to that diagram I had earlier. And in here, I've got my supervisor agent. I'm just going to walk through some elements of that. Lots of import statements at the top, some logging, because we like logging. And then we've got a supervisor system prompt. You can see it's quite long. I'm certainly not a prompt guru at all. I find that with prompting, there's still a lot to learn, and you've got to tweak it a little bit. To get your model to do exactly what you want to do, there are some hard do's and there are some don'ts. Sometimes you need to tell it different things when you're testing it. So what I would say is if you're going to build a solution, test it, see what it does, because it might surprise you, and then you need to refine that. What I've also done down here is I've started to tell it what tools it has available to it. So I'm saying to it, look, to do your job, you've got these tools. You can go away and do them, and I describe what each of those tools does so that the agent knows. The next session here is some classic Boto 3 session. When you go into the actual strands, it doesn't require you to do this. It will pick up your session, but you can get additional configuration by doing it this way. You can see here that I've opted for Claude Sonnet 4. Out of the box at the moment, it's using Claude Sonnet 3.7. So that just allows you to change it. And the one thing I would say is that you need to have this little US dot or, EU, wherever you're based, because the way it works at the moment is depending on what region you're in, is it will go to another region. It uses, I'm trying to think. Inference, yes, to do that. So it shares it. So you need that US piece on the front, or EU, or whatever region you're operating in. And you can get that information either from the CLI, from Boto 3, or just go to the console, of course. Here we can see that we've got our agent. So if you go into strands, you're constructing this agent, and then you can see that we've just given it these tools. Now, some of the tools are built in. File read, file write are both built-in tools. It gets that out of the box. You just have to import them. And then you've got these custom tools that we've given it, the execute checkoff command, get checkoff help, validate file paths, et cetera, et cetera. HTTP request is also a built-in tool as well. So these are just the tools that we give it. So if you don't have this bit, it doesn't matter how good your prompt is. Your prompt can say you've got access to the world, but if you haven't specified them here, it's not going to do anything. Okay, so that's pretty much all I'm going to show you. The rest of this is kind of like just the making it work bit. The next piece I want to show you is the tools itself. So the tools are just imported up here. And I separated them out just for clarity as well. Let's go and pick the Chekhov tool. So I think probably a lot of you know Chekhov is an open source scanning tool. It's well maintained. It releases almost every week. So it's a really good tool for checking a number of different things. Infrastructure as code in particular, but it will also do Kubernetes, so Terraform, CloudFormation. I like it because it's got something like 3,000 checks, and it's just got great coverage. So how do we define what the tool looks like? We use a Python decorator, @tool. So if we put @tool at the start here, what that basically does is it wraps the function, and then as long as it's imported into your agent, that is basically you telling your agent, discover this, and you can use it. Okay? Just for absolute clarity, when you go into the Strand site, what you can find is that your agents can also be tools. So you can have a model where you can have a tool, which is just some Python, but you can also make an agent itself a tool. So it's a bit like turtles all the way down. You have a supervisor, and you then make another agent also a tool of the supervisor, and then that tool, that tool will then have a tool. So in theory, you could chain another agent on the end of that. Everyone with me? Everyone following? Okay, good. I just want to sort of get that out there. And actually, I think it's one of the reasons why it's good to separate out the kind of the hard tools, the Python tools, from the agents. Because otherwise, like if you were to put this all in one file, basically everything's going to have a tool decorator on it, and you're not going to have a clue what's going on. So that's how that's kind of constructed. The only other thing I want to kind of bring your attention to with this Chekhov one is, if you actually have a look, those of you that are familiar with Chekhov will know that the command is something like Chekhov -d, path to some directory, -o, JSON, and sure, you can construct like that path if you want. You can say, go to a directory, scan everything in it, and give me the output as JSON. You won't see that here. Why don't you see that? Because I'm letting Gen AI figure it out. I'm basically not telling it what to do. I'm basically saying, here's a directory, here's some files. You go and figure out what command to execute. And then it just basically is doing a sub-process run. So this stuff here, this is Python, right? So if you kind of see this and go, yeah, well, there's probably a tool out there that does all of this already, and I can go and pay a third party for that. You can, absolutely. But the point we want to get across is like, this is just Python. If you have your own tools and you want to build an agentic front end on it, you can do that. As long as you can run some Python, run a command line, use sub-process, you can start to build these things out yourself. Okay, enough of that. Right. So where are we going to go next? Hopefully this is going to work. This is the bit that, I've just refreshed my credentials, and it might not work. We're going to find out real quick, right?
And while you're doing that, so I think the important point Charles is also making is that it gives you that sort of a platform independence where you're not actually just relying on, I have this particular CI/CD tool and I want to actually run it with only this tool. It's like makes it work with any tool you want or any CI/CD you have adopted.
This works better in rehearsals, eh? There we go. Okay, I'm going to let you into the secret source of AWS code presenting here. Normally, I'd have another monitor, but it's really small up here, and the other monitor is the PowerPoint that you were looking at earlier on a separate computer. So just bear with me, okay? I have not memorized all of these from scratch, okay? Okay, you get to see the speaking points as well. Pro tip, if you're ever doing one of these and you're using, generative AI to help you with this, what's really good is it knows the code base better than you. So you can say, I'm doing a demo, and help me write the demo. And this is what it'll do. Okay, so the first thing I want to do is we went through the Bodo 3, the session. That was all, we went through that. And the next thing I want to do is I want to kind of show you how we are trying to hit the actual the endpoint. So if we kind of, I'm going to move this up a bit, I'm going to move that across. So on the split terminal here, on the right-hand side, as you look at it, what we've actually got is a health check, which is just coming back from our API endpoint, which is effectively just a local Docker container we've got running, and it's just returning this health check. So the next thing I'm going to do is I'm going to try and run this command here and see if this is going to work. This will be the first test of whether we're going to jump straight to QA. Oh, no, we're not going to QA. You've got to continue hearing me a little bit more. OK, so let's just see if this is running. And I'll explain, like, I've got an API, but who likes running curl commands? And we don't. So I've wrapped that now in a CLI. OK, this is why I'm running these commands right now. But I will show you that it's an API under the hood in a bit. So effectively, it's saying it's connected, and it's found what we need. Let's see if we can get the health check. Good, that appears to be working, which is handy because it mirrors exactly what's on the other screen. That would have been very awkward if it hadn't worked. So the next thing I'm going to try and run is I'm going to try and run this curl command, where I'm just going to hit the API endpoint. And what have I got in here? So effectively, I've got a path to a file, which is conveniently, the developer is called EC2 Insecure, just to help me out. And I've got, you can see, a prompt. So the prompt is simply scan the CloudFormation file in, file reference, for security issues, and make specific recommendations. And let's see if this is going to work. OK, so hopefully on the right-hand side here, you can see the telemetry that we're getting coming off the Bedrock agent. So again, like if this was in CloudWatch, we'd all be waiting patiently for CloudWatch to show this because it's not in real time. But we can see that actually it's going to go through various stages, and it's going to talk. So that perfect, the Chekhov scan is completed successfully, let me know. That is not me. That's not hard-coded. That's Bedrock telling me it's doing a perfect job. Has everyone noticed that with their Gen AI agents? The thing I like is when you go, no, you've done it wrong, this is the problem, and it goes, you're absolutely right. Everyone get that? Does it just like make you boil inside when you point out, like, you're absolutely right? So what's appearing on the logs here is basically what is going to appear as the output from the API. So it gives you an idea that behind the scenes, Bedrock is doing stuff, but it's not going to return the result to me just yet. And I suspect you can change that functionality. So what we've now got is we've got a nice markdown file. Let's take a quick look at what it said. So first of all, it's given me the Chekhov scan results. That's good. I actually like that. The reason I like that, that's a confidence check for me, because I told it to use the Chekhov tool, and it's gone and used it. The thing that a lot of security people don't like is the fact that AI tools are non-deterministic, meaning they can make stuff up. They can change it. Each time you run this, it could change, right? So the way we make it deterministic is we use deterministic tools like Chekhov, and we then get the AI tool to analyze that output. Probably still not foolproof, but it's better than nothing at the moment. So the fact that it's told me which checks passed and failed is good. That's a good confidence boost for me, that it's actually producing something from Chekhov and hasn't just made it up itself. You can see here that it's also got CKV AWS 24. Again, that's a good confidence check that it's using Chekhov under the hood. Okay, so that was the API call, and the rest of this I'm now going to do by just basically the CLI command I've wrapped. We saw in the thing that I'd produced a little help function there, so it will return that help function. I've created this, ahead of time, I've created an insecure bit of Terraform here. So I'm just going to try and scan this file using the code here. In fact, let's move ahead. So on this one, I've said, give me the top most 5 critical. So the prompt starts running, and it's going to focus on the medium and high severities. What it's doing whilst I'm doing that is, like, if you were running this yourself, or you gave this tool to your developers, you wouldn't want them to spend their time writing prompts. So instead, what we can do is we can hard code some of those prompts into the CLI, and then it's going to give us a consistent way of asking each time. And that's exactly what I'm hopefully going to move on to. We might run out of time before we get to it, but one of the tools that we've actually also developed, which will show you the output, I don't know whether we're going to get to show you it working, is the fact that we can also raise issues in our Git repositories as well. So the way I envisage this being used is if you put this into commit hooks, you've now got that shift left. So the developer can have a prompt which is telling them early on when they try to commit something, it's going to do a pre-commit hook, and it's going to say you've got these issues, fix them. And then as you move through the development lifecycle and they get into actually pushing that code into the repo, then you can continue to actually have more stringent checks all the way up to an audit. The other thing I'm kind of quite excited about with this is, like, as security people, who here has ever mapped one thing to another thing? Have you ever noticed, like, no one is ever happy if you say, oh yeah, we've got this thing, they'll say, that's great, but how does that map to that thing? Yeah? So someone goes, oh, brilliant, you've now found 500 things that Chekhov says is bad. How does that map to the MITRE framework? How does that map to the AWS secure foundations? Oh, my days. You know when they say AI is going to put people out of a job? Like, this thing has that potential. Like, we're all going to have to, like, actually start thinking for a living instead of going, now, how does that S3 bucket relate to that security control, which relates to that, that framework, which relates to that? Like, these kind of things are going to be really good at basically doing that for you. So it's going to find something wrong with an S3 bucket, with an EC2 or instance or whatever, and then it's going to be able to have a tool which will say, I'm going to look up how that relates to that control framework. And it's then going to come back and say, if you continue down this path and you push this into your environment, what's going to happen is Security Hub and config are now going to have a finding against the AWS secure foundations or against CIS or whatever framework that you're choosing to use. So we can start to bring things together. So if you are doing that code review, you're now getting a report that tells you exactly the impact that you're going to see if you continue down that path. Because from a developer's perspective, they don't really care. They just see insecure buckets or insecure EC2s or whatever it is. But from a security and compliance perspective, you see everything as a compliance issue, and somehow we meet somewhere in the middle, yeah? So these tools are going to be really good at that. What else can we do? I guess you're probably familiar with this, but we can ask it to give us some fixes as well. So we don't have to kind of like ask developers anymore, oh, you're a naughty person and I have no idea how to fix it. That's your problem. Now, of course, we can go back to them and we can add value as security professionals. We can go back and say, hey, I need you to go and fix this thing, and here's why I need you to fix it, because of this framework that we comply to. Oh, and by the way, here's how you can fix it. Okay, suddenly that's making it really easy. It's up to you if you want to go one step further, which is, by the way, here's the pull request that I've automatically raised, just, pull that in and merge it. That's maybe a step you don't want to do. Maybe you want to have a human in the loop. Maybe your development team do not want the security team telling them how to write code. There are a few gotchas, like some of the things I've discovered. If you create an S3 bucket and you don't include logging on the bucket, it's going to come back with a finding saying there's no logging on this bucket. And it's going to suggest what we should do is create a bucket to put the logs in. So you'll end up with a code block that basically says your bucket and the other bucket that we're going to create for you to log to, which is one of those things. What are all the buckets that get found on compliance checks that have no logging enabled onto them? they're the logging buckets, but you can log to a logging bucket. But yeah, potentially there are still some rough edges. So the way that you can get around that is you can start to build in a knowledge base, retrieval augmented generation, give it a knowledge base. You can upload your security policy in there. So for example, there are probably exceptions in your organization that you're willing to accept. The example I'm going to give, maybe some of you think this is a heinous crime, don't shoot the messenger, but Lambda functions do not have to live in a VPC. Maybe that is something that you as an organization are like, okay, I can live with that. That's fine, it doesn't have to be in a VPC. Maybe it must live in a VPC. It's up to you. A lot of the tools that you're going to find that you can go and buy that will have a lot of features that are really good, and they are using AI, they might not have that customization. So if you're going to like go, Charles, I'm never going to go and build this, right? I'm just going to go and buy something, right? We've got budget this year, I'm going to go and buy something. Look for tools that will allow you to customize according to your policy. Because you're probably thinking, okay, Charles, why don't I just use Amazon Q? Why don't I just use like any of the AI tools that are out there to scan my code? Well, the thing is they're all kind of generic, right? You would have to give them that policy each time. So I would look for things that can give you that knowledge base. And it will be things like what are allowable exceptions, et cetera, et cetera. So go and look for those when you're choosing tools or you're building them.
Yeah, and just to complement that, one important point is also that, yes, you have the tools which can be configured as per your organization's need as well. But the tools like this actually adds that intelligence. For example, if your policy may be that I must not have any public S3 bucket, then you say configure my tool so that it actually allows that critical issue should not have that bucket. Or you can say, no, I will allow. So it's if and else kind of situation. Whereas with intelligence built in, it can actually go and figure it out that there is a reason you have public bucket because you have a static website from that public bucket. But that doesn't mean that rest of the buckets can be public. So to allow that inbuilt intelligence, tools like this with GenAI are really helpful.
So I want to leave some time for Q&A. And I know you've been here for a few days and maybe enjoying some hospitality in the evenings as well, or you're just like me and completely jet lagged. When I started out doing this, and again, I want to like go on the journey. Like you come across a compliance issue somewhere in Security Hub or config or just wherever you find it, and you take a look at it and you go, yeah, we should fix that. We should really fix that. And like maybe some of you have gone as far as automating those fixes. Right, bit of audience feedback. Who can tell me the problem with automating fixes? Like we've been able to do that for 8, 9, 10 years. What's the problem with automating our way out of the problem using config and Lambda functions? Anyone? Who uses Terraform? Okay. What does Terraform create when you use it? State file. So your developers are busy developing state files. What are security people busy doing? Creating stuff that ruins state files. Okay, not the file itself. The file itself is fine, unless it's going to the S3 bucket and changing that. But the problem you get is like you change the thing. And that's good from a security person's perspective because like, yay, happy days, Friday has come and Security Hub is looking fantastic. I'm on holiday. The problem is you've changed the configuration of half the things. And then a developer comes in on Monday morning, picks up their Jira ticket and goes, oh, that's a quick one for Monday morning, bang, 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 push. And the first thing the state file does is go and change everything that the config rule, which is like, to be honest, is great for Amazon revenue because like, you're just like changing things backwards and forwards, but it becomes a bit of a crazy situation as we're just changing things backwards and forwards. That doesn't work, okay? So automation definitely has its place. I'm not saying don't automate the problems. Like I think that there are times when it's worth it. And we haven't got time to get into the strategies about tagging and all of that stuff. But the issue you get is when you automate your way out of this problem, it's a big issue. Now, if your tagging strategy is really good, what you can probably see is the developer who created the thing. So you then go to the developer and say, hey, you created this thing, it's got a problem, can you fix it for me? Yeah, sure, no problem. Who in their organization is at that level of maturity?
Perfect. For
What company is it? Excellent. Can I come and be your consultant? I'm just like, that's brilliant. But no one else is at that level, right? Everyone else is now just looking at 3,000 S3 buckets that are configured badly and going, who am I going to talk to about this? Who do I talk to? So the answer to all of that is actually in your GitHub repo or Git repo. This just happens to be my personal one because I'm a low budget kind of guy and because we got rid of our own GitHub repo, or we're getting rid of it. But the information is all there. Like Charles is there. Somewhere there's a commit with a commit ID of some code that I put in. So this becomes like a fingerprint. Like literally your fingerprints are all over the crime scene when you're a developer now, because we can start to extract that metadata and we can start to pull it through into the tools and we can start to use that inside our bedrock as well. So now we've got Chekhov scans, we've got bandit scans. We're now pulling information from our Git repo, creating a unique fingerprint that tells us what the commit is. We're even able to go back and look at that commit, and it's going to tell us who committed the code. And it's even got information, if you're using code pipeline, it's even got information like the email address. So you could automate that. So instead of automating the fixing, we're now automating the process of going back to the developer and saying, hey, I know it was Friday, I know you were busy, but could you fix this for me? So we're starting to fix things at source rather than just automating our way out of the problem. The other thing that we can do with the tool is that we can create a tool around GitHub. I can tell you now, GitHub last week or so released, maybe it might have been earlier, someone might tell me, an MCP for their Git repos. So this is that interface between Gen AI tools and the actual things. If not, the APIs are there, you just write them, okay? You just write an API call. And if I show you what it did, you remember we were kind of raising our reports and you saw all of that data scrolling up the screen. Well, that was all Markdown, right? I know you were probably thinking that's not very pretty, but I could have saved it into a file and we could have looked at it. But if you take Markdown, stick it on an API, you just raise it straight in your GitHub repo. You could do that as a pull request. You could do that, it doesn't have to be an issue. You can tag it as security. You can tag it for the person who needs to fix it because they were the one who broke it. So what we're doing is we're shortening that loop dramatically. Like we're going from, like, okay, who's the people at the back, that company, you're in like what? How long would you think it takes detection to remediation? Minutes. So you're at minutes. Who here is at days? Who here is at months?
months or weeks, maybe.
Weeks. Okay, weeks. Weeks to detection to remediation. Who here works for a really old bank and you're in the like decades? Gentleman down there, you win. Like we all know, it's really hard to find those bugs. It's hard to find the people who need to fix them, and it's harder when someone has left the company as well. But that's the reality is like we can now go from commit, detection, firing it straight back into the GitHub repo, raising a pull request, and actually surfacing the issue, telling people exactly what's wrong, suggesting a fix. They can try it out. With the Strands tool I mentioned, or Strands SDK, I mentioned the fact that it has certain tools built into it. One of them is actually a Python environment. So what you can do is you can say, hey, I want you to go and detect the problem in the Python, fix it, and then I want you to test it beforehand. And you can also get it to say, does this actually fix my Chekhov problem? Keep going until you found a fix, right? So it can do that rapid iteration as well, and it takes minutes. So that's kind of, I think, all I've got to show to you. this is like about 1 million years off being production ready, okay? I'm not trying to sell you anything production. What I'm trying to sell you is the fact that I'm a security consultant who writes, I would say, average Python. I'm not an SDE. I don't have a background as an SDE. I have a background as an army officer. But I was able, with a bit of knowledge, a lot of sleepless nights, to produce something in Gen AI. Who was around for the dot-com boom? Who remembers that? Okay, dot-com boom. Do you, trick question, don't have to answer, but do you remember what the Amazon.com website looked like in 1995 when it launched? Yeah? Would you buy anything from it today? You wouldn't, would you? But we all did. We bought books because we thought we needed books. So my point is that I personally think that this Gen AI hype is not going anywhere. I think it's here to stay. I just think it's reached critical mass, but we are in the foothills. Take yourself back to 1995 and the Amazon website, looking at it historically and going, I would not buy anything from that today, but then just project forwards to where this could be. And I personally feel, and I'd like, this is my call to action for all of you. If some of you have been a little bit inspired by what I've said, go and look at the Strands SDK, get yourself set up, have a play, build something, play with it a bit more, because what you're doing now is you're going from a consumer of Gen AI to building the future of AI, just like once upon a time someone thought, yeah, I wonder how HTML, CSS works, like I'm going to go and build myself a website. Yeah. We all have to go through that journey, and I think that's a journey that's worth going on. And that's been my mission for this year, is to actually learn how to build with these tools and build something that is going to be useful for me and hopefully useful for you and my organization.
Okay, that's the time.
We are out of time. Thank you very much.
Thank you very much.
I really appreciate that.